Okay, so let me go back to sharing the screen. All right, so for those who came in late, we are working on this assignment, and we answered already the A and B and C part to question number 1. So just to briefly recap for question number 1, chemistry is that area of science which deals with matter and the changes it undergoes, right? That's for number 1A, that's chemistry. B, matter is anything that has mass and volume. And C, the scientific method is used by scientists to investigate and understand nature or natural phenomena, all right? So now we're on to D, and in D, you're asked, what do you understand by this word observation, which is the first step, by the way, in the scientific method, all right? So when we say observation in this context, what do you understand that to mean?
I guess detecting something in an experiment, like
Okay,
when you're like searching for a particular result.
okay.
Yes.
Okay, I would say that you're partially right, because you do detect something, but I'll be more explicit and say using our senses
Yeah.
to detect,
Yeah.
you know, whatever we're studying, right? So that could mean what you see, but it could also mean what you feel. You know, sometimes, even though this is not widely recommended, but in some cases, for example, if you have a reaction occurring in a test tube, you can feel the outside of the test tube, and in some cases, it will generate heat. In other cases, it will absorb heat. Odor as well. Again, I wouldn't recommend that in a lab. You'll stick your nose in a test tube and take a huge whiff. But again, in some cases, odor can be observed as well. So basically, you're using your senses to detect any changes that is taking place in a system that you're studying. All right. Okay, so that's D. E, the hypothesis, which is the second part of the scientific method. So what do we understand by this term? Hypothesis. I'm sorry?
Like your prediction of what will happen.
It's more than just a prediction. In fact, what you're talking about is, I think, the law, which we're going to get to in G. But the hypothesis, when we are making a hypothesis after the observation, what are we doing?
You're creating a educated guess on what will occur or what are the explanation of the event.
Exactly. It's and one important term which I think I stressed in the videos is that you're right, it's an educated guess, but it's tentative.
Yeah.
Right? So it's not the end of the story, so to speak, right? It's just a suggestion that you put forward to explain what you observe. All right, so it's basically like a speculative kind of explanation of what you observe in the first place. All right, so that's what the hypothesis is. It's basically an educated guess, a tentative educated guess to explain what you observe in the first place. All right, okay, so the next one is theory. All right, so in the scientific method or process, what do you understand the theory to mean?
It's the explanation following the experiment that you think best fits the results of the experiment.
Exactly. That's a very good way of putting it.
Yeah.
Another way of putting it is it's basically an explanation which is backed by the data that is resulting from repeated experimentation, right? So that's basically what the theory is, right? And it's very important that you understand the difference between the theory and the hypothesis, right? The hypothesis, as we said before, is a speculative, educated, tentative guess to explain what was observed. But the theory results from repeated experimentation repeated refinement of the hypothesis so that the theory and the data fits, or the data would fit the theory, all right? And then we get to the scientific law, which I think this young lady here was, what did you say earlier? You were saying something in relation to, I think it was the hypothesis, but it's actually sounds more like the law. So what did you say? You forgot? If I remember correctly, you said something about a statement that predicts what will happen, something to that effect, right? So basically, a law is a statement that that is true for a particular observation, for which there are no exceptions. That's another way of putting it, right? So basically, like for example, I don't remember if I gave you this example, but there's a law which I think we'll meet later on, which says that, let me see if I can write this down. Come on. Come on. There's a law called Moore's law, which says that the pressure of a gas is inversely proportional to the volume, right? So what that law says is that, basically what this law is saying, is that if you double the volume of a gas, the pressure will be reduced by half, right? If you triple the volume, then the pressure will be reduced by a third. There's an inverse relationship between the two, right? So basically, that is a law, right? That is what is observed every single time, without any exception, right? And one important thing I should mention here, which I don't remember if I stressed in the video, is that there's a difference between the scientific law and the theory, right? The scientific law does not explain anything. It just says what will happen. The theory is the explanation, all right? So, and the reason I mention this is because even I've heard, top scientists confusing the two, right? But it's important that you understand that the law is different from the theory. The theory is the explanation that is backed by data arising from experimentation, while the law is basically a statement of what is observed for a particular phenomenon. All right, let me get rid of this and scroll down. Okay, so now that we have done number one, we're going to move on to number two. And number two is dealing with the classification of matter. All right, so let me refresh your memory, because as I said before, you should have watched the videos. So matter, as we said before, is anything that has mass and volume, right? And on the matter, you can have two categories, right? You can have pure substances, right? And you can have mixtures, right? A pure substance is basically a substance that does not change in its composition, all right? While a mixture can have a variety of combination of, different components, right? Now, on the mixture, or I should say on the pure substances, there are two further subcategories. One is element, and the other is a compound, right? An element is a substance that can't be broken down into anything simpler, while a compound can be broken down into something simpler, right? And then we have mixtures. There are two types. You have homogeneous mixtures and you have heterogeneous mixtures, right? Homogeneous mixtures are mixtures that are uniform throughout. For example, if you mix sugar and water, stir it and all the sugar dissolves, then basically you end up with a homogeneous mixture. Now, if you add, for example, vegetable oil and water together and you stir together, what will happen eventually is that they're going to separate into two layers, right? The top layer will be the oil and the bottom layer will be the water. So that's an example of heterogeneous mixtures, all right? Okay, so with all that said, let's see if you can answer these questions under number two. So the question says you have to classify the following as a pure substance, which means it's either element or compound, or mixture, which means it could be either homogeneous or heterogeneous. So if you identify a substance as a pure substance, you need to say whether or not it's an element or compound. And if you identify the substance as whatever the answer is here, if you identify it as a mixture, then you should say it's homogeneous or heterogeneous. So, A, air, is that, well, firstly, is that a mixture or is that a pure substance? Sure about that? The air we breathe? Hmm?
Mixture.
It is a mixture. It's a mixture of gases. The main gas is nitrogen, and then there is oxygen, and then you have some other, I think carbon dioxide is the next one, and then I don't remember the actual percentage, but basically it's a mixture of gases, all right? So the answer for A is homogeneous mixture. It's homogeneous because basically, whoops, what did I do? Basically, air has the same composition pretty much wherever you sample it, right? It's going to have the same amount of nitrogen, oxygen, and other gases with the same percentage, right? So we say that's a homogeneous mixture, all right? Okay, what about B? A, nickel, which is a coin, by the way. Would that be a pure substance or would it be a mixture? Well, no. Actually, it's a mixture. And it's a mixture that is uniform. So we say it's a homogeneous mixture again. All right. Mixtures of metals, they're called alloys. Let me just put this in parentheses here. Alloys, right? So that's a homogeneous mixture. Okay, C, magnesium. Is that a pure substance or is it a mixture? No. It's a pure substance. So the next question is it an element or a compound? Exactly. So the answer here is that it's a pure substance. And I would add element. All right. Okay, what about seawater? Would that be a mixture or a pure substance? It would be a mixture. And what type of mixture would it be? Would it be homogeneous or heterogeneous? No, I would say homogeneous. Because it didn't say anything about like sand or anything like that in it. Just seawater. So I would say it's a homogeneous mixture. Okay, and the final one is gasoline. Is that a pure substance or is that a mixture? It's a mixture. And what kind of mixture would it be? Would it be a homogeneous or a heterogeneous mixture? Remember, homogeneous mixture is one that is uniform throughout, while a heterogeneous mixture would have like, two different parts, like two layers. So, heterogeneous? No, it would be homogeneous. Gasoline is a homogeneous mixture of a group of compounds known as hydrocarbons, right? So if you look at gasoline, you will see two layers, right? Okay, any questions about number 2 that we have just done? Any questions? Any questions?
Which one you said would be the two layers, the homogeneous?
Heterogeneous. Right, homogeneous will be uniform throughout, like gasoline, like salt and water. While that was homogeneous. Heterogeneous would have like, two, like oil and water, you have two layers. Or salt and pepper where you can see the difference between the two, all right? Okay, let me clear this here and scroll down. And I just realized there's a typo, this should be number 3 actually, but anyway. So this one now is testing your understanding of the terms elements, compounds, mixtures. And it says if any of these does not fit any of these three, then you just put an X. All right. So the first one is diamond, and you'll notice after diamond they put the symbol for carbon here because diamond is actually a form of carbon. All right. So what category would you put diamond in? Would it be an element, a compound, or a mixture? You sure about that?
No.
Let me give you a little hint. If you have access to the periodic table, all those substances are elements, right? So if you look up in the periodic table, you see carbon there, then it's an element, right? And the definition of element, of course, is that these are substances that cannot be broken down into anything simpler by chemical means. So here we're going to put E for element, all right? What about sugar? And they gave you the formula for sugar. Now that should give you a hint. Nope. The hint in this particular case is that they gave you the formula. And the formula gives you the fixed amount of each of the elements present per molecule, right? So one molecule of this contains 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms, right? So whenever you have a substance where the components are fixed, the elements are fixed, then that would be a compound. You know, kind of like H2O, where there's a 2-to-1 ratio between hydrogen and oxygen. Well, in this one case, it's a bit more complicated, but it's the same idea. The ratio of carbon to hydrogen and oxygen is fixed. So therefore, this will be a compound, so we're going to put C here. Okay, what about milk? Would that be an element, a compound, or a mixture? It's a mixture. Excuse me. So the answer here is M. Okay, what about iron? Exactly. Excuse me. E, okay. Air, we mentioned this before. Nope. What did you say about air to answer earlier question? It's a what? Mixture, exactly. Air is a mixture of gases, nitrogen, oxygen, carbon dioxide, and some other gases. Sulfuric acid. Here they gave you the formula, just like we did here. Would be a compound. Yeah, exactly. Gasoline. We mentioned this before, actually. Mixture, exactly. Electricity. Nope. What's that? Exactly. It doesn't fall into any one of these three, so we put the letter X. All right. Krypton. Exactly. Bismuth. Exactly. Uranium. Right again. Popcorn. It's either an element, compound, or mixture. So what would you say popcorn is? Mixture. Okay, water. Compound. Alcohol. Compound. A pail of garbage. Mixture. A dog. No. No. Exactly. Ammonia. compound, salt, compound, energy, exactly, X, gold,
Element.
Hmm?
Element. Element.
yeah, element. Okay, I take it it's okay for me to clear this, right? Let me scroll down here. Yeah, couple more here. Wood. Yes, sir.
Are we supposed to have this on paper or no?
Oh, it's not on it?
No. 2 and 3.
Oh,
are-
shoot.
the rest of
Okay,
them.
that's my fault then. Oh, I know what happened. This morning okay, I changed the setting for printing. This morning, and when I was printing this, I forgot to. Okay, this is available online, right? In Canvas, so you can print that and fill in the answers. All right, and submit it. I apologize for that, that's my fault. Okay, so we just continue with this. Okay, where was that? Wood. What category will you put that in?
Next,
Mixture. Bronze.
It's a mixture.
It's a mixture. Bronze is a mixture of two metals, the name of which I can't remember right now, but it is indeed a mixture. Ink,
Also a mixture.
that's a mixture as well. Pizza,
Mixture.
mixture as well. Dry ice. By the way, dry ice is the same thing as frozen carbon dioxide. So is that, what category would you put that in?
Pure
A compound, exactly. Baking soda, a compound. Titanium,
element.
element. And concrete,
Mixture.
exactly. All right, very good. So, let me clear this here. And scroll down. Okay, so this question says label each of the following as either physical process or change or chemical process or change. So let me just recap the meaning of those terms. So a physical process is one that occurs, but that does not involve a change in the composition of the substance, right? So for example, let's say you have liquid water and you heat it to form water vapor. That would be a physical change because even though there's a change in state, but you still end up with H2O, which is the same as the H2O that you had before, all right? So there's no change in the composition of the substance. A chemical change is one where there is a change in the composition of the substance, all right? So for example, an example of a chemical change would be the spoilage of food, for example, all right? Or the burning of gasoline. Those are examples of chemical change because those are actually reactions where the products will be different from the reactants, all right? Okay, so with that said, let's see, what's the answer for 3A? Metal gets warmer. Is that a physical or chemical change? Metal gets warmer. Is that physical or chemical?
Physical.
Physical, because the metal composition is not changed, right? So that's physical. The explosion of nitroglycerin,
Chemical.
chemical.
Because the chemical actually breaks apart at the molecular level.
Well, it breaks apart and form other products.
Yeah.
Right, which is different from what you start off with.
Yeah.
Corrosion of iron metal, is that a physical or a chemical change? Corrosion of iron metal, is that physical or chemical? Chemical is indeed correct. Because iron, upon corrosion, forms a new substance, which is iron 3 oxide, also known as rust, all right? Okay, water condenses on the metal. Is that a physical or chemical change?
Physical.
Physical, right? Because condensation is basically the vapor converted to a liquid. So there's no change in the composition, just a change in state. All right. So let me clear this here and scroll down. Okay, now here we're talking about physical and chemical properties, which basically is a parallel definitions to physical and chemical changes, right? So a physical property is a property when observed does not involve a chemical change, and a chemical property is one that when observed involves a chemical change. So iron forms rust on exposure to air and moisture. Is that a physical or chemical property? Chemical. Okay, zinc has a density of 7.13 gram per mil at 25 degrees Celsius. Is that physical or chemical? Physical. Silver is a lustrous metal. Lustrous basically means that it's shiny. Physical. And zinc dissolved in dilute hydrochloric acid producing a hydrogen gas. Chemical, exactly. All right, very good. Okay. Let me clear this and scroll down. Now this question, it says match each diagram with its correct description. The diagrams will be used once. In other words, there's no repeat answers when it comes to assigning the diagram, all right? Now, basically, this should be obvious, but let me just say this anyway. So basically what these represent, the circles represent atoms, and the black circles are different atoms from the white circle, right? So basically each of these represent what is described below. So for example, A, pure element, only one type of atom present, right? The answer for that would be C, right? Because there's only one type of atom present, so turn on that pen here. So the answer here for A is C. Now B says a mixture of two elements, two types of uncombined atoms present. Now the answer for that would be E, because you have white circles here and you have the black circles and they're not combined. So therefore the answer for B would be E. So since I've done the first two for you, what do you think is the answer for C? A pure compound where there's only one type of compound present. Hmm? Correct. B would indeed be the answer for C. Okay, what about D? Mixture of two compounds, two types of compounds present. A would be the answer. And E, a mixture of a compound and an element. Hmm? D, yep. And I think that's it. Let me see here. Yeah, that's it. Okay. So let me clear this. All right, now for number 6, they're asking you to convert the following numbers into scientific notation, right? So basically, when we're talking about scientific notation, we're talking about something that looks like, I'm just going to make up an example here. 2.57 times 10 to the 3, all right? So there are two parts to a number expression scientific notation. You have this part, which is called the coefficient, and then you have this part, which is called the exponent, right? Now, basically, to get from these numbers to the scientific notation, you have to be careful. So let's say you're given 135.9 and you're asked to write this in scientific notation. That means you need to bring the decimal point up here to where the 1 is, right? So that means that decimal point will move 2 places to the left. So you're going to end up with the coefficient 1.359. 1.359, right? But you have to multiply by 10 raised to the exponent. And what is that exponent? That exponent would represent the number of places that the decimal point moved to the right. So it's 1, 2 places to the right. So that would be 1.359 times 10 to the 2. All right? That's one example. Now, in another example, if you're given 0.0467, then to write this down in scientific notation, you have to move the decimal point 1, 2 places to the left to get the coefficient of 4.67. Then you multiply by 10 raised to the minus 2 because you move the decimal point 2 places to the right. So therefore the exponent becomes minus 2. So the answer becomes 4.67 times 10 to the minus 2. All right. So with that said, let's see if we can do 6a. If we're to convert this to scientific notation, the decimal point is understood to be here. The decimal point is understood to be here, right? So you'd have to move the decimal point 1, 2, 3 places to get a coefficient of 3.4. And because you move the decimal point 3 places to the left, the exponent becomes 3. So therefore the answer would be 3.4 times 10 to the 3. All right? Okay, so how would you do the B part? 0.000023 expressed in scientific notation.
(2.3 times 10 to the negative 5).
2.3 times 10 to the 1, 2, 3, 4. Yep, minus 5. Very good. What about the next one? 101, 101,000.
1.01 times
1.01 times
10 to the 5.
10 to the 1, 2, 3, 4, 5. Yep, 10 to the 5. Okay, next one.
1 times 10 to the negative 2.
Okay, 1 times 10 to the minus 2. Technically speaking, it's 1.0, but if you don't include that for now, I'll accept that. Okay, what about the next one?
4.501 times 10.
Times 10 or 10 to the 1, yep. What about the next one?
4.0 times 10 to the 6.
1 times 10 to the 6. Okay, what about G?
6.71 times 10 negative 3.
And then the last one.
There. RE times
4.50 times 10 to the what? 10 to the 0. Okay, very good. All right. Any question about any of these? Any questions? Questions? All right. Let me clear this here. Let's scroll down. Okay, now in this case, we're going to do the reverse. You're given a number in scientific notations, and you're asked to write down the same number in standard notation. So what would be the answer for the first one?
increase 1,000.
23. 1, 2, 3. 1, 2, 3. Yeah, that's it. What about the next one?
$1,760.
Nope. You have to move the decimal point in the other direction. Because this is 10 to the minus 3. So what do you think the answer is?
.0.00176.
Exactly. Okay, what about the next one? 10 to the minus 7.
.0.00000019.
6 zeros.
Zero.
And then 1901. Okay, what about the next one?
.8665.
Okay, the next one. 9.11 times 10 to the 3.
$9,110.
Okay. What about the next one? Okay. What about the next one?
$1.76.
Exactly. And then the last one.
.0.000074.
One, two, three, four, five. Oh. I think I have 1 0 too many. Okay. And that's it for that question. All right, let me clear this here. And let me scroll down. Okay, now for this part, you're going to do some conversions, right? Within the metric system, right? So for answering questions like these, you need to know what the prefixes mean, and I provided in the table those prefixes so you can use those during your test and so on. So I'm just going to do one of these, and then I'm going to leave the rest in this question for you to do on your own, all right? So for this one, you want to go from milligrams to grams, right? Now the milli means 1,000. So what does that mean? That means that 1 milligram is equal to 1,000th of a gram, or 10 to the minus 3 grams, right? So if you want to convert from milligrams to grams, we start off with 25 milligrams, and we multiply by a conversion factor, which converts from milligrams to grams. So this here would be expressed in this conversion factor, where we have 10 to the minus 3 grams above and 1 milligram below. And the reason why we have it arranged in this way is so that this will cancel out with that, right? And then you're going to end up with your answer, which is 25 times 10 to the minus 3 grams, which is equal to 0.025 grams. And that's basically how that is done. All right. And if you understand this, then you should be able to do the others. So I'm going to leave the others for you to do on your own. If you have any questions about them, feel free to contact me about that, right? So I'm going to leave the rest of number 7 for you to do on your own. Let me clear this. And let me scroll down. Okay, now this here is a table, obviously, which basically leave some spaces for you to complete based on whatever information is provided for each element, all right? So you can see, for example, in the case of copper, they gave you the number of protons, they gave you the number of neutrons, and they gave you the number of electrons. And your task is to figure out what the symbol is, the atomic number, and the mass number. So let's review what we mean by the term mass number and atomic number. Let me talk about the atomic number first. The atomic number is, it's down here. The atomic number is equal to the number of protons in the nucleus of the atom, right? And each element has its own unique atomic number, right? So for example, if you go to the periodic table and you look up the element, let's say sodium, sodium has 11 protons, right? So its atomic number is 11. Or if you look up, I don't know, look up nitrogen, nitrogen has 7 protons, all right? So that's what the atomic number gives you. And then the mass number is equal to the sum of the number of protons plus the number of neutrons. All right? So for copper, the symbol is Cu. You can look that up and find out that the symbol is Cu. And then now for the atomic number, remember I said that the atomic number is the same as the number of protons. And the number of protons here is 29, so the atomic number here will be 29. Now the mass number, as we said before, is the sum of the number of protons and neutrons, right? Here we have the protons, here we have the neutrons. So what's 29 plus 35? 9 and 5, 14, carry the 1. So that's 4 plus 2, 64. And that would be the mass number, if I did that right. All right? So that's basically how you complete that line in this table. All right? Any questions on this? Any questions? Any questions? Okay, so in the case of tin, they gave you the name, they gave you the formula, they gave you the number of neutrons, and they gave you the number of electrons, right? So therefore, what's the atomic number?
Electrons must be, is it, so we're assuming that the ion is neutral, right?
Yeah,
So it
the
must,
neutral atom.
so it must be the same as electrons.
Exactly.
Yeah.
Or you could look it up in the periodic table.
Yeah.
Right? As I said before, each element has their own unique atomic number. So you could look at the periodic table and determine the same thing, right? Okay, now if 50 is the atomic number, what is the mass number based on everything else? Now remember the definition of the mass number, it's the sum of the number of protons plus the sum of the number of neutrons, right? Here we have the number of protons. Well, which would be the atomic number anyway.
But it's not possible for you to like actually calculate the number of neutrons offhand because that's very particular to the atom.
So the neutrons are not particular to that, the protons are.
No, I mean like, what I mean is it's very particular to like the arrangement of protons, so you can't like actually calculate it in your head, you have to look that up.
Well, if you're talking about the protons, you can look that up, yes, in the periodic table, yeah. But the number of neutrons, now you have to calculate it based on, or the mass number, you have to calculate it based on the number of neutrons added to the number of protons. You see what I'm saying? So therefore, this is the protons, this is the neutrons. So 50 plus 69 gives you what? That looks like 119. All right? And that's basically the row for tin. Okay, now for iodine, well, I gave it away already. This is iodine, which is I, right? So how do we complete the rest of this line right here? What's the number of protons in the case of iodine? 53. What's the number of neutrons? Yep, 74. And the number of electrons will be 53, exactly. All right. Uranium, what's the symbol? U. And what's the atomic number? I don't have a periodic table here, or no, I can probably look it up. If I remember correctly, the atomic number of uranium is 92. But I want to make sure. Let's see. Yes, that was correct, 92. So I'm gonna put 92 right here. And the number of protons will be what? What will be the number of protons in the case of uranium? 92. What will be the number of neutrons? 146, that's correct. And okay, we already have that. Okay, so that's basically it for that row. Okay, for the next one, Kate, that is a symbol for potassium. And the atomic number is what? 19. The mass number is what? 29. And the number of electrons will be 19. All right. What about lithium? The symbol is? What's the symbol for lithium?
Li,
Li. The atomic number is?
3,
Okay. The number of neutrons will be?
4,
Uh-huh. And the number of electrons will be? Huh? 3. Exactly. Okay, then we get to this row. O is the symbol for oxygen. The mass number is?
it's gonna be 16,
16. The number of protons will be what?
8,
8. And the number of electrons will be 8. All right. Okay, let me clear this here. Okay, the next one is gold. What's the atomic number? You know, let me make this smaller here. Hold on. Okay, okay, so in the case of gold, the symbol is Au. And what will be the number of protons? 79. What will be the number of neutrons? 118. Okay, yeah, that's correct. And the number of electrons? 79. All right. The next is what's the name of the element for the next one? They gave you the atomic number, they gave you the mass number, and they gave you the number of protons. So what would be the symbol here? Or what would be the name? I'm sorry.
16, would that be,
Yeah, that's a hint right here. 16. What element has the atomic number 16? This is where your periodic table will become important.
So
Sulfur.
yeah,
All right. And the symbol is S. So what would be the number of neutrons here? 16. And the number of electrons here would be 16. Okay, very good. Now for silver, the symbol is
Ag,
Ag. And what would be the number of neutrons here?
61.
I'm sorry? 61. And what would be the number of electrons here? 47, all right. And then the next one is, okay, so what will be the name of the element here? The symbol is CO. So what element has that particular formula?
Wow. Chromium.
No, not chromium.
You skipped.
No, you skipped.
Oh, I skipped chromium? Oh, my bad, okay. So chromium, what's the symbol for chromium here?
CL.
CR. And what's the atomic number? You have to look that up. In the periodic table. Or, hold on,
Electrons.
they gave you here actually. So that would be 24. The number of electrons, the number of protons would be the same. The mass number would be what?
52.
The mass number would be the sum of the number of protons, which is 24, plus 28. So that's what? That looks like 52. All right. Okay, the next line. The symbol is CO. So what's the name of the element? Nope, CO, not C. What element has the formula CO?
Cobalt.
Cobalt. COBALT. Okay, what is the atomic number of cobalt? 27. And the same will be for the number of protons. And that's it for that line. Okay. What about the next one? What's the name? Ni.
Nitrogen.
Nope. Nitrogen is just N.
Nickel.
Exactly. Okay. And what would be the atomic number of nickel? Hmm? 28. And then the mass number is what? Hmm? What's the mass number?
56.
What's that?
56.
56? Nope. The answer is we don't know. Because we don't have the number of neutrons, right? Without the number of neutrons, you cannot calculate the mass number, right? So I will put a line like this. Oops. Sorry. I'll put a line like this for the mass number and a line like this for the number of neutrons. Because without the mass number, we cannot determine the number of neutrons or vice versa, right? And what about the number of electrons? 28, exactly. All right, I'm going to leave the rest of this table for you to complete. So basically, that's pretty much it for today. So basically, you need to complete this assignment. Let me hold on. Let me clear this here. And let me I'm going to create a portal for you to upload your assignment. Okay, so assignment number 1. Okay, so today is the 20. 5th. Okay, so I'm going to let the deadline date be the 28th.
The deadline for this,
Yeah,
How are we supposed to submit that?
I'm about to explain. Give me a minute, let me just make sure that things are in place here. So it's available from now to the 28th. Okay, so the way you're going to submit it is, firstly, you need to scan your assignment when you complete it and save it as a PDF document. And then you'll be able to upload that into the Canvas system. Please make sure it's in the form of a PDF document, not the other formats like what's the other one, JPEG and PNG or whatever, right? The PDF works best as far as I can see with Canvas, so please do so, all right? Also, let me remind you that the college will be closed next Monday because of the holidays, so please don't come, all right? So I'm going to post all the videos for you to watch in preparation for the next class, which will be week after next Monday. All right? And that's basically it for today, folks. Unless there are any questions. Oh, you have a question?
This and the one before.
Well, everything. What you can do is print the missing pages from the document because the full document is in Canvas. Let me show you where it's located. If you go to Files, and then go to Assignments, and then you're going to see Chapter 1, right? So you're going to download that. So you can basically download the missing pages and complete that as well. All right?
And so we need to download the whole assignment.
Pretty much, yeah. Okay. Any other questions? Any other questions? Okay, so if there are no other questions, that's pretty much it for today. I'll see you guys week after next Monday. All right?